Hi, and welcome to this lecture on the STEAM inquiry model. Now, this is an idea that colleagues and I, that you can see listed on the board there, in the partnership between Griffith and QUT, where we've been working on a theoretical model that will help us understand STEAM, the idea of STEAM, science, technology, engineering, arts and mathematics, and inquiry. So bring those two ideas together, okay? So the inquiry project that you'll be doing in weeks 6 to 8 is based on this theoretical grounding that we're going to have a look at today. So just as always, the learning objectives are, as you can see. So we're going to have a look at the whole argument of, is it STEM, is it STEAM, and why should it be STEAM? And well, we're going to make the case that it should be STEAM, and for good educational reasons that I'll outline here as well. Then I'll go into a little bit more detail in terms of the model, in terms of understanding why those particular letters are actually in the acronym and no others. And then, importantly for your project, I'll start talking about the STEAM sliders and also a little bit about how weeks 6 to 8 in this course will actually run, okay? But let's start with why do we use STEAM and not STEM, okay? Now, if you go to the font of all knowledge, Wikipedia, and you actually look up STEM in the educational context, you come up with a long list of different varieties of how STEM has been conceptualized out there. So you can see there's been other letters added, there have been letters dropped, there have been new words created. What this really indicates is that there really is no firm understanding of what STEM actually is, because people are just taking the idea and running with it. Okay? What we propose to do in our inquiry model is to nail it down to say that, right, STEAM is the correct acronym that we should be using, and there are good educational reasons of why that should be, and how you can bring that in to the pedagogical approach of inquiry-based teaching. So let's go through how we actually then decided what letters should be included, okay? So our first thought should be, is that whatever should be included, what we need are inclusion criteria and exclusion criteria. Now, when you have a look at science, technology, engineering, arts and mathematics, they are really disciplines. They're kind of broad umbrella categories that smaller disciplines and fields, not disciplines, fields fit into, okay? So what we did is we developed a set of inclusion criteria and a set of exclusion criteria. So you can see there, to get your name, to get your letter as part of the acronym, well, you need to fulfill these 4 criteria. You need to have a primary function. So that means there needs to be an associated epistemology, ontology and praxis around the fields that you're looking at. There should be clearly defined products of your field. So science, if you want to be in, then you must have clearly defined products. Mathematics, if you want in, radio, cough up with the defined products. And the last key point, because we want clear definitions, clear barriers between the disciplines, what we want is a clear point of difference between the disciplines. And you can see here, if you scroll back and if you have a look at the various acronyms, what we thought was, well, you know, if you're mentioning skills, then yeah, that you don't get included. If you're mentioning school subjects, then yeah, you're not included, or the nature of work, or the particular focus that your particular program has, okay? So we thought that, radio, anything which mentions any of these, you don't get in, okay? So then we use the Frayer model. So the Frayer model, if you're not familiar with it, looks like this. And the first thing that you do is you look at the concept, and there you can see in the middle, which is a discipline. We're trying to define a discipline because only disciplines get a letter in the acronym, okay? So then we listed some examples. You can see some there. Not only do you need examples, but you also need non-examples to have a clear defining line, because we're defining a word, in terms of what is a discipline and what is not a discipline. Okay? You can see some examples there. We then fleshed that out. So then we looked at the examples and we thought, rightio, when we look at all these words there, what do they have in common? Well, they have unique methods, they're the largest, most general category, they have a primary function, and also they have unique products. So once we completed that analysis, then we landed on the definition of a discipline being the most general category of a collection of fields unified by a unique method or set of methods of inquiry. Okay? And that's a really important distinction that we made, was that the processes within each of the disciplines must be unique and they must be an inquiry method. Okay? So then we came up with this definition, in that the STEAM fields, the disciplines, are the tools that we as humans use to answer questions, solve problems, and create products. Now, you might want to pause on the next screen because there are examples provided of each. So you can see they're listed, the 5 different disciplines which made the cut and actually got into the acronym. But then what we did, we broke that down into the methods or the processes which are used, and we've clearly defined that for each of those. We've looked at the primary purpose, the products. We've linked it also to school subjects so teachers can more clearly see how the discipline relates to the various subjects that we have in schools. And then we've also linked it to professions as well. Okay? So that was the first thing that we absolutely needed to do, was define what a discipline was, because only disciplines got a letter in the acronym, and then they needed to fulfill each of these criteria that we had set that you can see on the board. Okay? Rightio. So let's go on to justifying why STEAM is the appropriate acronym and why they belong. Okay? So we can actually look at the STEAM fields, because remember how I was saying earlier, the STEAM fields are the tools that we use to answer questions, solve problems, and create products. Well, when we map that against Maslow's needs hierarchy, what we can see is that technology and engineering, they're the fields which help us meet our basic needs, generally. Okay, so safety and physiological needs, we have technology and engineer technology which helps us meet those basic needs. Then we've got the science and mathematics. So these are the fields which generate knowledge, and they help us address and meet our needs pretty much in the whole spectrum. Now, the cool thing about the arts is that they help us achieve, once we've achieved our basic needs of physiological needs, safety, and belonging, well, the arts helps us meet our esteem needs in terms of prestige and feeling accomplished, but also self-actualization. So being able to express who we are and being able to explore who we are, being able to reach our full potential as human beings, that's best done through the arts. Okay? Now, another reason why it's actually the STEAM fields, the STEAM disciplines, and why they're the ones, because when you look at the real world and real world issues and real world problems and real world products, we find that they're actually not completely separated. They actually interact and they work synergistically to create a whole bunch of things. Okay, so let's take a couple of examples from this image here. So once upon a time, there was a guy called Galileo, and he had a tube, and he put a lens at one end and thought, oh, cool, look at this. I can actually see very far away. Like if I put 2, then I can see even further far away. And then if I turn it around, it's like, oh, wow, I can see really small. So what you've got there is the intersection of technology, lens grinding, optics, meeting science and being able to further the fields of biology and also astronomy. Here's another example. This is a fun example down here. So this is from the Disney cartoon Brave, and this is the intersection of arts and mathematics. So our understanding and our exploration of fractals from the branch of mathematics actually then meets with the technology of coding and within the arts to be able to produce this amazing work of art. And so the particular problem that they managed to solve in Brave was modelling how hair interacts in the real world. And so they wrote code And so it was for the first time within a cartoon where they had super, super realistic hair. And you can see that in all future Disney movies and Pixar movies, okay? Another quick one over here is the interaction between science and the arts. Now, you might notice that painting over there is it is a Picasso who was a Cubist. And the interesting thing about the Cubist movement was that it really arose out after Einstein's landmark work around special relativity and general relativity, and how that whole idea of relativity and being able to see a three-dimensional object in two dimensions. So it's not just somebody who does not understand how anatomy actually works. That's actually a representation of if you could see in three dimensions, yeah, and represent it on a 2D. So if you were able to see in a higher dimension, you would actually be able to see every single angle of a person, and that's why you can see both their eyes and all those other features that you can see there. So the fields don't exist in isolation. They actually work together and build off each other and help spur each other on, okay? So this is a much nicer presentation of the phrase that we had earlier, because not only are they the fields, the inquiry tools to help us answer questions, solve problems and create products, but taking it to the next level in terms of authenticity, particularly within education, making sure, well, or trying to ensure that the projects that we work on make a difference in students' lives or the lives of others. Okay? So that's the whole point of doing science, technology and mathematics, is not so that you can perform a test, but so you can do these things with real world problems, real world issues. Okay? So just to stop to summarize quickly, that what we've got is that the STEAM inquiry model are tools that students, teachers and also researchers can use to not only communicate with one another about a particular project, okay, but also to be able to understand how to approach their project, and you'll get to experience that when we get to the lab section. Okay, so there's three key elements. There's an understanding that the STEAM fields work synergistically together. There's understanding over here that they are tools for us to use if we want to do those three things. And then the new object that I'm going to introduce you to is the STEAM sliders, and this is going to be fairly important for when you do the project. Okay? Now, if you are as old as me, you may be familiar with these. Okay, so you'll see representations of this graphic equalizer in more modern context, but in the good old days, they actually used to be physical objects that you can move up and down. Okay? Well, when we think of STEAM and how we now combine that with the idea of inquiry, when you are investigating real-world problems, real-world projects, conducting an inquiry, what you're actually doing is you're drawing upon the 5 fields to varying degrees. Some you'll use a lot, some you'll use not so much. Some you'll use a little bit, some you'll use not at all. But so if you pause to have a quick think about those 3 examples that you can see on the board, and you start to think deeply about, rightio, what do I want to know, what do I want to do, you start quickly realizing that you're actually going to draw upon your mathematical knowledge and processes, your scientific, you may need to do a science experiment, there may need be a product that you need to create, and so therefore you'd use the technology engineering process. Whatever it is, you're going to be relying on those 5 fields. Okay? So when we started out, we conceptualized the STEAM fields as being sliders. Okay? So in our project, we can use a lot of science or not so much, a lot of the arts or not so much. Okay? And so that's one dimension of this particular tool. The other dimension is that the amount of each that you use. Now, it's not really, you can't quantify, oh, I used 6/10 of science and I used 2/10 of engineering. What it's more about is the depth that you use that particular field. So if you engage if you have a low level engagement with the field, then you're probably just using the tools from that field. A little bit higher up, you're probably going to be drawing upon the knowledge and applying the knowledge. But if you're going to say that, oh, I'm doing science, or I'm doing the arts, or I'm doing technology, then you really should be using one of the processes from that field. So you can think back to the definition. To be a discipline, you needed a defining method or set of methods which are unique to your particular discipline. So this is an early iteration, and what we've done is over the years we've updated it so it looks more like this now. Okay, so you can see we've still got the sliders, we've still got the scaling, we've still got the rough, processes up the top, and then applications of knowledge, and then the physical tools down the bottom. But what we've done is we've provided some examples to help people using the tool to be able to more effectively gauge where they are. Okay, so for example, if you are using a paintbrush to paint, I don't know, a poster, yeah, you can't really say, oh, I'm an artist now, because really anybody could be using a paintbrush, and it's quite a low level engagement with the arts, okay? A little bit higher up, however, if you're using color theory, yeah, so if you're using your understanding of warm colors and cool colors to be able to compose a piece, poster, which is able to communicate an emotion, then that's obviously a little bit higher up in terms of being an artist, because you're applying knowledge and you're still using the paintbrush and the paints, but you are doing it with a little bit more depth and a little bit more understanding. Then, if you are then going to use an artistic process where you go through and you plan and you create and you exhibit and you go through the artistic process, then that's when you can say you are being a true artist, when you are incorporating, you're using the processes that an actual artist would use. Similarly for the others. So if you're using the scientific method, then great. You are doing science, you are being a scientist. If you're using Polya's method, problem-solving method, then excellent. You are being a mathematician, you are doing mathematics, okay? So the reason why we have this is because when projects come into inquiry-based teaching scenarios like you're going to be going into, it's sometimes difficult for students to decide like, oh, well, how do I even approach this? How can I approach this project in a rigorous manner that will help me achieve my goals, okay? So that is the slider that you will see in weeks 6 to 8. So this is kind of a snapshot from the use last year. So as part of our research, what we're going to ask you to do is, okay, so have a look at the sliders, have a look at your project, kind of predict how much of each of the disciplines you're going to use. So make a prediction before we start. Write some definitions, just what you currently think, and then we're going to repeat that at the end, okay? So here, have you changed your mind? We'll go ahead and change your mind to whatever you think it is going to be, and see if your understanding of STEAM and STEAM inquiry has changed in that time, okay? Now, when we run this research in schools, obviously it is a multi-week, multi-lesson kind of approach. So you can see here, here's a fairly typical scenario where we've implemented this idea within the classroom. So week 1, week 2, all the way down to week 7. However, we've only got 3 weeks. So we're going to cram it into 3 weeks. So what you saw here, 7 weeks, down into 3 weeks. But that's okay. You'll be able to manage, okay? So just to give you a bit of a sense of what's going on, we're going to do some brainstorming with you, okay? So we're going to have a look at real-world questions, problems, and products that you can brainstorm. So we'll give you some stimulus, and you're going to come up with a whole bunch of ideas for possible projects. Then we're going to classify them into questions, products, and whatever the other one is. I can't read it there. And so if anyone is stuck for ideas, if any groups are stuck for ideas, then you can come to this list and you may borrow somebody else's ideas. We'll give you tools to help you decide on a project. This particular tool, the decision-making matrix, you'll be able to find in the course text. Once your group has decided on your project, You'll do some justification, as you can see there. Then you'll start your project, okay? So you'll use this basic template like you have with all the other previous labs, but then you'll be more explicitly using either scientific method, technology engineering process, if you're doing some art stuff or some mathematics stuff, doesn't really matter. You're going to determine that and we're going to help you. So by using STEAM sliders, and we're going to have a look at your inquiry question, inquiry problem, and we'll help you decide which is the most appropriate process or processes for you to use. So for example, if you decide that, okay, I need a scientific process and I need the mathematics process, that's great. Then you're going to use both of those, okay? But we'll be working with you closely on helping you to decide that. So then you're going to be filling in a template like this. This is the one from last year. There's going to be slight changes to this. So once again, here are the learning objectives. So we have defined what STEAM is and how we came to that. We've made the argument for why STEAM inquiry is an important thing to bring into the classroom. We defined what each of the various letters of the inquiry are, and we've also introduced the STEAM sliders. So thank you very much, and I will see you in the lab.